In previous videos, we explored methods of comparing two independently sampled populations. So, for example, comparing the number of sales in a store in the United States against the number of sales in a store in, say, Japan. In this video, we're going to start exploring how we can compare population means for two populations that we cannot make the assumption of independence. So, for example, two electronic stores in the same town making sales on the same day. So to do that, we're going to try to motivate our example, and we're first going to compare, again, the number of sales for two different stores in the same town on the same days. So we're going to look at our x1 and our x2 as the sales for those two different stores, and we're going to create a hypothesis test. So our hypothesis test is going to be testing h0, where we're going to say mu1 is minus mu2 is equal to our d0 value of 0. And then our alternative hypothesis is we're just going to test to see if they are actually different. So we're going to say mu1 minus mu2 does not equal our d0 of 0. To conduct this hypothesis test, we know that we're first going to need to calculate SP squared. So we're going to do that up front. So we have our SP squared is equal to the formula of n1 minus 1 times our s1 squared plus our n2 minus 1 times our s2 squared, and all of that over our n1 plus n2 minus 2. So if we fill in our values here, we have our n1 minus 1, so we have our 6 times our s1 squared, or our 3.215 squared, so 3.215 to the second, plus, again, our 6 for the number of samples, times our 2.769 squared, and all that over, we have 7 plus 7 is 14, minus 2, so we're going to get 12 on the bottom. And if we actually conduct all that math and carry that all out, we get an SP squared value of 6.75. Now we're going to plug that in to our t value, or our test statistic. So we have t is equal to our x1 bar minus our x2 bar minus our d0, all that divided by the square root of our SP squared times 1 over n1 plus 1 over n2. And we'll fill in those values. We get x1 bar minus x2 bar. We get 124 minus 122, so we get 2 on the top, minus that 0, so we're just going to ignore that. And then we get the square root of SP squared, or 6.75, times 1 over 7 plus 1 over 7, which gives us the square root of 7.036. And we finish that all off, we get our t value is equal to, we get t is equal to 0.754. And if we're going to compare that to our t sub alpha over 2, if we set our alpha level, we're going to use alpha of 0.05. And we fill that in. We have our degrees of freedom of 12 now, since we have 7 plus 7 minus 2. So we get our t of alpha over 2 is equal to 2.179 is t of alpha over 2 with 12 degrees of freedom. And we can see that our t value is indeed less than our t sub alpha over 2. So that means we are going to fail to reject our h0 value, or our hypothesis test. So we're going to fail to reject our null. But if we actually look at each of these individual values, if we compare x1 and x2 for each of the different days, we can see that x1 actually outperforms x2 in every single day. So if we look and see which one is larger, we have x1 is larger on the first day, x1 is larger on the second day, third day, fourth day, fifth day, sixth day, and finally the seventh day. So x1 is outperforming x2 on every single day that we look at, but we're still failing to reject the null hypothesis to determine whether or not their means are actually different. So in upcoming videos, we're going to be looking at methods that we can actually use to compare these, to get a test statistic that actually makes a little bit more sense and kind of shows us that our x1 is outperforming our x2 in every day.